In the frame of the second International Web Conference on Forecasting, I will present to you my work about the regression trees and solar radiation forecasting, the boosting, bagging, and ensemble learning case. There it is, the summary. First, an introduction. In second time, the data and preprocessing of the data. After, I talk about the forecasting method developed in the frame of this work, the results, and the conclusion in perspective. First, the introduction. The power grid management is a difficult task. Indeed, the balance between production and consumption have to be respected at each time. The challenge is nowadays to reduce the environmental impact maintaining a supply quality. Integration of renewable intermittent energy source complicates the electrical grid management. The network manager needs a visibility on the PV, photovoltaic, and wind production at various time horizons. The forecast is an indispensable tool. The utilization of forecasting method is time dependent. Here we can see the time dependency with forecasting error versus forecasting horizons. For little horizons, real-time based models. For 1 hour to 1 day, the time series and ground measurements based models. And for horizon more than 1 day, the meteorological forecasting. In electrical production management, the horizon for PV production is very short term, as intraday. The utilization of time series based models is a good solution. In this presentation, we will talk about nowcasting 1 to 6 hour horizon. Now I will talk about the data and preprocessing. First is to measure the data used in the development of the models. Here it's a global horizontal irradiance measurements in ODU, 1 year of availability with time granularity of 1 minute. Here it's the localization of the station, and here 1 year of data. The preprocessing of data needs different steps. First, the measurement of global horizontal irradiance, GHA. After, the quality checks in order to know if there is gaps or outlier values. When the quality control is approved, we made the clear sky modeling, SOLIS model. It's a knowledge model in order to stationarize the time series of the measurements. We compute the clear sky index. The different steps are resumed here: quality check, cleaned time series, clear sky computation, and stationary time series. Then we continue the preprocessing of the data with the filtering. Hours with solar elevation less to 10 degrees are removed, and the use of information theory as auto-mutual information to calculate the historical data needed to use the models. Here is the formulation of the forecasting models. Here we have the forecasted value at horizon H. F is the function characterizing the models. Here the past measured values, and here the forecasting error related to each model. There is the general formulation of modeling. Now I will present to you the different forecasting methods used in the frame of this work. The forecasting is based on aggregated machine learning methods. We use 4 methods: 1 naive method used as a reference, and 3 aggregated regression tree based methods. The different models used are detailed here. First, the naive method. The smart persistence is simply a persistence improved by the utilization of the knowledge model, SOLIS model. And then the regression tree based methods, the boosted regression tree, the bagged regression tree, and the random forest. These three methods are the aggregated models. Now I will present the results. We evaluate the performance of the model by the computation of normalized root mean squared error. Here it is a graph and the table of the different results. We can see that the random forest is the most efficient models with normalized root mean square error of 28% for 1 hour horizon. After, the baguette regression tree is the best model. We can see too that the boosted regression tree are the less efficient of the aggregated model, and the smart persistence is the worst model, but used as a reference. Here we have another graph in order to have another view on the results. It's the normalized root mean squared error versus horizon for each model. We can see the random forest is for first horizon the best forecaster. After, the baguette regression tree is better. The smart persistence is the worst model, but we keep it on the graph in order to have a reference for comparison. And the boosted regression tree gives always little less performance on all horizons, but we can see that the aggregated models have sensibly the same performance in all horizons. We have several conclusions to pick up. First, we made a data acquisition and pretreatment with quality check. It's a very important task. We have 1 year of availability to perform the training and the development of the different models. The simulation with 4 models of different machine learning models, naive and aggregated. Random forest and baguette regression trees are the best models in this case. Indeed, the other machine learning models give good performance too. We have some perspective to pick up of this work. First, to extend the study on other datasets provided for other sites with different meteorological conditions, in order to have the generalization of selection models method. The hybridization is a good perspective too, in order to take the best performance of each method at each horizon. And then the improvement of the performance during the cloudy days, they are the most difficult to forecast, use of the other forecasting methods. Thanks for your attention.